So as we continue on into 6.3, we want to start building these confidence intervals for the population proportion. So again, the way we do this, we have to use this point estimate, which is going to be this sample proportion. We're going to subtract the margin of error to get the left bound, if you will. And then we're going to have the sample proportion, and we're going to add the margin of error to get the right bound. So that's going to get us our confidence interval. So we're going to use this formula here to actually create our margin of error. So we're going to have this critical value Z, and then we're going to take the square root of, and notice how we have P hat, which is the sample proportion of successes, times Q hat, which is the sample proportion of failures, and we're going to divide that by the sample size. So again, this all kind of is tied into some other things. Like we said, we have to have normal distribution has to be involved as well. But remember, some things that have to hold true is for us, this n times p hat has to be greater than or equal to 5. This n times q hat has to be greater than or equal to 5 as well for us to kind of move forward in our problem. So as we move into our guidelines for constructing a confidence interval, this is kind of what we'll be doing. Is we'll have to identify the sample statistics, X and N. So that's going to give us our point estimate, P hat. We also need to verify that our stuff is normal distributed, and also make sure that N P hat is greater than or equal to 5 and N times Q hat is greater than or equal to 5. So we have to have some of that mentioned. We need to identify our critical value Z. We also have some shortcuts for that. We don't necessarily have to use our table for that. I may pause our video and see if I can search those back up because we wrote those down somewhere. So we'll write those back down here so we don't have to look those up every time in our table. And then we'll use this formula here to actually find our margin of error. And then this will allow us to create our confidence interval. So let me pause a second and see if we can actually find those critical values C from the previous section. So recall from 6.1, we kind of made note of these critical value Z's that a 90% confidence interval, the critical value Z was 1.645. 95% confidence interval, the critical value Z was 1.96, and a 99% confidence interval, I think we used 2.575. Now remember, if you're using our calculator, I'll just do one of these. But remember, if it's 90%, remember the 90% was the area between the two critical values. So remember that 90% was located here. So that was like that 0.90 is here. So remember, if that's 90%, that left us 10%, which meant that 10% had to be left for over here and over here. So it was like 0.05 and 0.05 over here and here. So if I was using our calculator, I could find that critical value Z by going to the distribution. And remember, number 3, inverse normal. Notice how our area is always from the left, so we can use that 0.05. And since we're doing Z values, the mean and the standard deviation are 1s and left. And if we do that, notice how we get this negative 1.64, and then notice how that 8 makes that move to a 5. There's that. That would have been a negative 1.645. But notice how, remember, because of symmetry, that negative 1.645 would also give us the positive value of a 1.645 because of symmetry. So that would allow us to get that critical value over here as well. But like I said, instead of doing all that, it seems like these were the ones that were most commonly used. So we just kind of made a note of that, so we didn't have to go look those up every time in the calculator. Okay, so let's go ahead and look at this first example here. Using the data in example 1, construct a 95% confidence interval for the population proportion of US adults who use Facebook. So I believe in the data, I think we said that the sample size was, there's 1,550 people surveyed. And I believe 1,054 said they used Facebook. So if we go back over and look at our question, 1,550 were surveyed, 1,054 used Facebook. Okay. So what that allowed us to do was determine our p hat. So p hat was going to be this 1054, that was our successes, divided by the sample size, which is the 1,550. And we'll go and do that math again here. 1054, if we divide that by the 1,550, that gives us then this 0.68. So notice that Q hat would be the 1 minus the 0.68. So 1 minus 0.68 would be 0.32. So basically, 68% of our sample were using Facebook, and sorry, that's 32% were not using Facebook. Now, something else we have to kind of verify is, does n p hat, is that greater equal to 5? So if we go 1,550 times this 0.68, that's got to be greater equal to 5. That clearly looks like it will be, but we'll go ahead and just do that math just to show you. 1,550 times 0.68, that is 1054, which makes sense. So that 1054 is greater than equal to 5. And the other thing is, does the 1,550 times the 0.32, is it also greater than equal to 5? So does the 1,550 times the 0.32, notice how that gives me 496. Notice how that is indeed also greater than equal to 5. So that tells us that we can pursue on working on determining our level of confidence. So since the confidence level is 95%, we know that our critical value Z at a 95% is going to be this 1.96. So we don't have to go look that all up. So from there, we can then find our margin of error. So it's going to be this formula, 1.96, and we're going to multiply that by the square root of p hat, which is 0.68, times then q hat, which is the 0.32, and we're going to divide that by the sample size, which is n. So if we do that, 1.96 times then the square root of, I'm going to go ahead and use the fraction button. So if I do the alpha button and hit the F1, so hit the y equals button up here, I can create the fraction, and I can put the 0.68 times the 0.32 in the numerator. And then on the bottom, I can divide that by the n, which we said was actually, oops, I think it was 1,550. if we put a 1550 there, that's gonna give me then this 0.032. I think a lot of times our margin errors have been rounded to like 2 decimal places, so I'm not really 100% sure, but we're going to round it 2 decimal places, so 0.02 there. So what I can do then is to find our left endpoint, we're going to have p hat minus c, so 0.68 minus 0.02 is going to be less than p, and then it's going to be this p hat, which is the 0.68 plus the 0.02, the margin of error, gives us our right side. So what's that going to be, like 0.66 less than p, which is less than 0.70. If we want to double check that, we can. 0.68 minus 0.02. 0.66, so we'd have that. And I think a lot of times in your homework, it may be interval notation. So 0.66 would be your left bound, and the 0.70 is your right bound. Now, what we can do, though, is since they're just asking us to do the confidence interval, there is a shortcut using your calculator that allows us to bypass all this math. So notice how this is actually going to be, we're going to be using tests. So we're going to be using the stat button on your calculator to start with. So if we hit the stat button on your calculator, and then if we go to test,
I send them off.
so if we slide over to test, and then here we do the z interval.
You have enough starch to keep it from being wrinkled, and it feels like that.
We enter there. Gives us some fields here. No, that's not the right one. Let me pause here a second. So let's try that again. So we'll quit there and go to stat, go to test, and then it's actually, we're doing the proportion one. So it's actually this one with a alpha, this a one prop z interval test. So stat test and then one prop z interval. If we do that, hit enter. So notice how it asks us for our sample successes was the 1054. And then our sample size, whoops, did something wrong there. Stat test. I'm gonna use the shortcut alpha A 1054 1550. Our level of confidence was 95%, so that stays there. If I calculate, notice how it gives us this 0.656, so that would round to 0.66. And then notice that 0.703 would round to 0.70. So notice how that would give us our confidence interval without having to actually calculate that margin of error. So it kind of bypasses that step. Now, some of your homework questions will ask you to find the margin of error, so you'll have to use this formula. But if you're just trying to do the confidence interval, you actually could just use your calculator to do that.